before I start to talk on this topic, quick intro about me. First of all, I think that the lunch was awesome. I didn't know if you tried the falafel. It was really, really, really nice. So, intro for me. Bojan Jakimovski, machine learning lead at Loka, master in dedicated computer systems, AWS ambassador, and 9 times AWS certified. Also, I'm a college professor at the Brainstar Next College, so I'm teaching students about machine learning and AI. And in my free time, when I have some free time, I tend to contribute to open source, mostly on Hugging Face projects or AWS-based projects. So I'm developing a Python library for synthetic data generation. Really interesting topic. If you have some ideas on that field, feel free to stop me later and we can talk on that topic. But I'm sure that you're not about me here. You're about this interesting topic. So it's the title says Model Context Protocol, MCP, the backend that the AI agents understand. So from the early morning, we've talked about agents. You can see everywhere agents. Open LinkedIn, open Twitter, X, any social media, agents. So, bro, I'm building some fancy AI agent startup, etc., etc. And really, this topic is quite popular these days. But the point is that everyone talks about agents. And as this slide says, AI agent is like teenage sex. Everyone talks about it, but no one knows how to do it. Everyone thinks that they know how to do it, so everyone claims that they know how to do AI agents. But the main thing is, yeah, everyone is talking about AI agents. We said multiple times that this is the year of AI agents. Some of the big guys in tech said that 2025 is the year of AI agents. Even Greg Brockman, the co-founder of OpenAI, had a tweet about this. So that's why you see this topic quite a lot these days. And it's getting boring, right? But the main question here is, okay, like, what the hell is AI agent? Or what is an agent? So, agent. The idea for agents comes from reinforcement learning. But I think that's a really complex topic, and we do not want to play around and to explain all of this stuff. But the main idea comes from there. However, these AI agents that we are building these days are more simplified version of the real agent thing. What you need to know is that the AI agent or agents these days is nothing else than an LLM with a for loop that triggers something. So each of us can build an AI agent quite easily by pinging an LLM endpoint and like running a for loop with some tools, with some planning, etc., etc. But here I want for you to grasp 3 things. That every AI agent today has 3 components. The first component is the planning. So what will be executed? And most of this, let's say, thinking, reasoning process is done by the LLM. So what will be the next action that it will be executed? The next thing is the memory. So what we've executed previously. And here we have 2 types of memory, short-term and long-term. So what we did in the last 5 prompts and what we did on a session level or, I don't know, conversation level, etc., etc. And lastly, you can see tools. So what are the actions that can be done by the agent? And here we talked about tools. In the morning also some of my colleagues talked about tool calling, etc., etc. And the question is, okay, what the hell is tools, or what the hell are functions? So functions or tools, whatever you use, whatever term you use, is nothing else than a code function that you are writing it and the LLM is capable to execute it. So that's with some other terms, some other words, probably you've seen that on the internet, it's called function calling or tool calling, which is nothing special, right? For example, on this slide, you can see that we have an agent, something fancy schmancy, and we are asking the agent what is the weather in New York for the next 5 days and what is the current time. And the agent thinks, so it reasons, it does some planning, it invokes one tool, which is to get the weather for the next 5 days in New York, and also to get the current time. So everything is summarized by the LLM, and we have the output of the system. So what can be a tool or a function or whatever we want to use? It can be any simple Python JavaScript code. So it can be a function to, I don't know, send an email, to list to-do tasks, or something like to list a file system, to update or extract some knowledge from a database. It can be a structured database, NoSQL. It can be even a vector database. So everything is possible. But there's a problem in function calling and then in tool calling. The biggest problem is that function calling and tool calling are done differently by every LLM API provider. For example, OpenAI has function calling. Claude has used in the past, I think, tool calling. Gemini, Google DeepMind copied something else. Mistral, something else. And it's not standardized. And that's a big problem. Like, extremely huge problem, especially if you build a system that needs to be modular, model agnostic, and needs to be, let's say, scalable. That's a big problem. The next problem about scalability is also that the functions are defined on the same side as the main agent. So imagine you have an agent, right, which spends some resources, system resources, but on the same side you have a tool, right? And the tool and the agent spend the resources, so you can easily overclock your system, and that's not a good practice. Do not go deep dive into the problems that can happen also with the security or with the data governance. So there are some critical stuffs that can happen, and why it's not the preferred way to use function or tool calling. It depends on the LLM provider, right? So we need some unification. We need some standardization. We need something that is usable by every LLM API provider, by every open source model that can be hosted on our machines, on our servers, etc., etc. We need a protocol, right? We are engineers, we build protocols. So we need MCP. What is MCP? Okay, this is a good question. What is MCP? Imagine MCP as USB-C for AI agents. So MCP allows us to plug and play any tool. It doesn't matter, we use, I don't know, Claude, SLM provides, so Anthropic, or OpenAI, or we host model locally. We can have a standardized way of having the tools to be accessed by our system. So there's a question in these days, if you open the social media, you can see like, okay, why to use MCP? First of all, you can use MCP to leverage the growing ecosystem of tools, of hosting providers, of LLM clients, because, for example, I know that I've built some MCP servers with some tools about, I don't know, working with GitHub repos. Probably someone else from you would want to use some similar tools, so why to build it from scratch when you have already built it and you can like run the MCP server and use it in your own AI agent. The next thing is standardization. So you have a standardized way, you have a well-structured way, you can have a way of having stateful connections, and you can have easily context management on most of the stuff. And by the end of the day, because everyone uses MCP or everyone builds MCP servers, and if you have like multiple people, a big environment or big community of developers that build MCP servers and MCP clients, in that case, you're sure that you will have support on your building your own system or your own AI agentic system, how we call it these days. So this is an example of how a typical general architecture of MCP looks like. So you can see here we have two environments. So we have a local environment and we have a remote environment. Something that I want for you guys to remember is the three entities that are part of every MCP application or any, let's say, application that utilizes MCP servers. First, by default, is the host. So the host is basically the AI application that runs or uses the MCP server. Host can be basically everything. So from Claude Code, Cursor, it can be your own AI agent, your own AI agent backend, whatever. So that's the host. The second is the client. So the client basically connects to the server and extracts and manages the requests and responses, gets all the available tools, all the available prompts, resources from the server, which the LLM, or in our case, the agent, can utilize. And lastly, we have the server, which basically exposes the tools, exposes the resources and the prompts to the client. And as I said, on this slide, we have an environment, like a local environment, where we have a host. Usually, these days, it's an IDE, because from the previous sessions, we saw that there's a lot of use case in utilizing AI agents and LLMs in general for code creation and code generation. So usually that's one of the hosts. So we have MCP protocol that communicates with different MCP servers. For example, we have MCP server A, which is connected to some local database. Local database can be documentation of our API or some readmes that can help the agent to actually have better outputs. We have another MCP server, which is, for example, connected to a third backend server that is like on remote environment, totally different place. Or we have an MCP server C that is connected to a backend server, which are on the same remote environment. So if you see this architecture, this general architecture, you can see that the possibilities are endless. When we talked about MCP, we must know the 5 primitives that are part of every MCP application. So we have 2 big primitives on the client side. So TLDR, as you can see, it's a typical client-server architecture, right? Client-server way of having a system. The primitives on the client are roots and sampling. And now the question is, okay, what the hell is roots? So roots basically provides to the MCP server all the available roots in the system of file systems to be able to, for the LLM to query. So by this way, we are restricting the system to not access any additional file systems that it doesn't need to access. Sampling. So on the sampling side, on the client side, with sampling, we can use, the server can access the LLM to invoke completion, so any type of invocation of the LLM, without providing API keys, without providing any security credentials, etc., etc., which is quite important when you build production-ready applications, especially AI agents. And on the server side, we have 3 primitives: prompts. Yeah, we all know what are prompts, but usually prompts on the server side are some system instructions for the agents. We have the tools. By default, we know what are the tools now, and we have resources. Resources are really interesting primitive on the server side, and resources are used mostly as read-only data. So if you have any read-only database, then you can define that as a resource or a S3 bucket that can be used as an additional, let's say, context for the whole AI application. Then you can define a resource. So if you see most of them, the question is, what is the most important primitive or most used primitive? Question for you. Tools? I see some tools. Yeah, if you open any MCP server on the internet or see an MCP a developer using MCP servers, they mostly use the server, the tool server primitive. Now, I want to talk more about the layers. So we have 2 important layers into the whole, let's say, MCP ecosphere, which is the transport layer and the data layer. So the transport layer is the layer that is dedicated only for exchange mechanism and defining the channels which can be used to do basically the transport of data between the client and the server. So all of the mechanisms that are connected to authorization, sending messages, receiving messages, are basically done by the transport layer. The data layer is nothing else than the JSON RPC protocol. So a client-server communication, which includes the lifecycle management and the core primitives. If you think about on the global scale, on a bigger picture, the transport basically is the outer layer of the MCP, and the data is the internal, so the internal layer of the MCP. Yeah, about the transport layer, and this is really, really important because today there's a big topic, big discussion on this topic. So what type of transport layer or transport protocol we can use when we build MCP applications? There are two. So there's STDO, and STDO is basically where we use the local input output data streaming of the system. And in this case, with STDO transport layer, we do not use any network. So if you have an application that is AI agent and you're building it on your own local system, then by default, I would go with STDO. However, if you want to build a remote MCP server, and most of the applications today are going through remote MCP servers, at least big AI agentic applications, then you will go with streamable HTTP. And what is the idea with streamable HTTP? It's basically like any HTTP protocol, and it allows authentication with bearer token, API keys, OAuth 2.1, etc., etc. Something that is really important to pinpoint about the transport layer is that on the initial version of the MCP protocol, they didn't figure out the authentication quite correctly. So that was a big error, and they fixed it, I think, 2-3 months ago, early June. So yeah, now with streamable HTTPS, you can say for sure that you can provide security on your MCP server. And now the question is, okay, Buki, how we can build MCP servers? So, or MCP clients, or any MCP application. There's a big community, official community, that builds SDKs for multiple languages. So JavaScript. How many of you are JavaScript developers? Okay. Python? Woo, Python? Java? Okay. So you have Python, JavaScript, TypeScript, Rust, Go, PHP, Kotlin, Swift. So there are a lot of SDKs available that can be utilized to build MCP applications. So both MCP clients and MCP servers. If you know me, you know that I'm a machine learning engineer and machine learning lead, so I enjoy Python, and I'm Python fan, so I'm using Python to build MCP servers and MCP clients. In particular, to build MCP server in Python, you can use something that is called fast MCP. However, now I think this is the essential of this today's talk. To find the difference between classical backend written in Python and MCP server written in Python. So you can see here we have Fast API. How many of you use Fast API? Nice. So we have two endpoints, simple get endpoints. So to add two numbers and to multiply two numbers. And on the, this is my left side, so probably you're right. You have an MCP server, which is also a calculator server, and you can see that it looks pretty much the same with small difference. So this is basically the crucial moment of actually figuring out that MCP server is nothing else than a backend for AI agents. So you can see here that it's quite easy to build an MCP server. And now the question is, okay, but I have a Fast API backend. Can I build instantly from Fast API an MCP server? Sure you can. And you can do that in one line. So if you use Fast MCP, you can import from Fast MCP, import Fast MCP, you can define the MCP from Fast API, and instantly you have that. So this is the beauty of Python. At least now I'm a Python fanboy, but I will stop it here. You can see that it's quite fast and quite easily build an MCP server if you have a backend that already exists. And this backend now can be accessible by the LLM. So previously you had a classical backend, you need to ping it by curl, Postman, or your front-end application, but now this backend can be used by your agent. So we came to the conclusion that this is a backend, right? Not AI ML stuff to be done. And really, that's true. And there are a lot of discussions, especially we had this discussions internally in my company in Loka, that building MCP servers or building AI agents is really less an AI ML job. It's more backend job, and the backend folks are like, yeah, you are right, but the ML folks are, no, you're not right. You need to know ML. You need to know transformer architecture. Blah 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 blah. But this is the truth. And now, if we know how to build MCP servers, we need to access those MCP servers. How? So we can build clients by the SDK, official SDK. However, we want to utilize already prepared clients, right? And we want to utilize some of the bigger frameworks for AI agents. So my top go-to these days is Trend Agents. It's really awesome framework. Not that I'm contributing to it, but I really love it. It's an open source model agnostic framework from AWS. But you have the classic LangChain, Llama Index, you have Crew AI, and you have plethora of others. For example, there is really good framework from Google, ADK, OpenAI has its classical agent framework. So whatever you choose, you will not miss. This presentation can be boring if we do not see some code and some architecture, right? So let's build a simple MCP server with an MCP client built in Strength Agents using AWS, but we are going to use an already prepared test API server. So if you can see the architecture, this is nothing, some fancy schmancy stuff. I think each of us can do it. Whatever you are, front-end engineer, back-end engineer, DevOps, AI/ML, whatever you guys work, this is really simple. So we have the user, we have a mystical creature marketplace agent. You will see it, what it is. And we have an MCP server with multiple tools. So to list creatures, to get a creature, to adopt, etc., etc. And the main actor in the whole story is Amazon Bedrock for LLM. So for the guys that do not work on the AWS ecosystem, cloud ecosystem, Amazon Bedrock is the service that provides access to multiple LLMs. So all of the state of the art, from Llama, Claude models, now GPT-OSS, Qwen from yesterday. So it's quite a good service to be used as let's say cloud provider, API provider for LLMs. Plus it's HIPAA, GDPR compliant. That's always a selling point. So now I would want to showcase you a demo. Can you see it? It's drama with the sun. So you can see on my right side, you can see on my right side that I have a fast API. So a typical backend for mystical creature marketplace. So we have some pedantic models that define the entities. We have the fast API. We have some static database. We have all of the tools that are available, etc., etc. And we have also an MCP server. And as you've seen on the previous slide, to build an MCP server from fast API is only one liner. And on my right side, we have the agent, which agent is built by Strength Agents. So we use a simple MCP client, we have a session manager, and from Bedrock we use the Amazon Nova Premier models, which are quite good, cheap, and fast. They can improve with accuracy, so it's not state-of-the-art, but they are getting there. And for testing purposes and development purposes, I tend to use them. So let's execute most of the stuff. So it was running in the background, but yeah, I will reset it. The first thing we need to do is to run the fast API. So we are using UVcorn. We use UV, so you can see that the fast API server is already running on port 8000. We can also run the fast MCP. So fast MCP is also running. Good. And finally, we are going to execute the client. And the prompt that is used on the client is what mystical creatures are available right now. Let's see. So you can see that some of the tools are pinged. So something is executed. We have the Nova model that is thinking. So it invokes tool1 to list the creatures, and now we can see like the mystical creatures that are available in our database. And what we can do is, for example, let's use some other tool. Let's use to release the creature. So let's change the prompt. Can you please release who we want to release? Let's go with Professor Hoot, the Owl Wizard. And now we expect first to list all of the available creatures, and then to utilize another tool which will basically release that creature. Oh, so it already, because it has a session management, so it already releases the Professor Hoot, and even they left a note for us, like thank you for the adventure. So it's a pretty interesting, let's say, AI application. By the way, all of this code is available on my GitHub. So after the sessions, you will have a QR code to scan it and to play around. I want for you guys to see that it's quite easy to build MCP servers and to utilize it in different applications. And besides that, besides building MCP servers and MCP server-based applications, you can find already existing MCP servers. So a couple of days ago, the official guys from MCP, which are part of the Anthropic team, released an MCP registry. So that's a whole ecosystem of MCP clients and MCP servers, basically like an app store for MCP built applications and servers. You can find it there, and you can work around with different type of MCP-based applications. On the other side, because I'm AWS fanboy and I'm working with a lot of AWS, there's a quite good, let's say, registry of AWS MCP servers where you can work around with AWS services by using MCPs. In fact, I'm building one for a big MLA service on the AWS ecosystem. So for the guys that know, can throw an assumption. And finally, we have Awesome MCP servers, which is a really interesting website where you can find different type of MCP servers from the community or even from official teams. For example, you have MCP servers from GitHub for working with the whole GitHub ecosystem, or you have with Playwright, etc., etc., etc. So you have, let's say, a large number of MCP servers, clients, and applications to work around and to play around. And finally, I think after this short session and after everything we said today, now you can officially open an MCP SaaS 2.0 company or startup, and you can start to sell your MCP server. Happy MCP.